All right, guys, let's quickly look at this. One of the most 12. A block of mass. Please let time to read. A block of mass 100 kg is sliding down a rough. Okay, very key points. That's the point I'm underlining so far. It has a mass. It's sliding down. It is rough. When we mention rough, we talk about what? Friction. Okay. Surface at a constant speed. Very important as well. When you see constant speed, it means acceleration equals to 0. Net force as well should be equal to 0. Why? Final velocity is the same as initial velocity. Okay. Now, the kinetic frictional force is 0.29. Please, let's quickly talk about this. This will not change. They like this question. This will not change if theta changes. And what is my theta? The angle of what? Inclination. Whether it changes, whether it decreases or increases, it doesn't matter. The coefficient of friction will not change. All right. Will not change. Okay. So, definition, guys, everyone should be able to do that. Define the term frictional force. It is the force exerted by the surface of the object and it is perpendicular to the surface. Please get your 2 marks. This is the most important that people don't want to pay attention to. The free body diagram. That's the most important. If I were to check your free body diagram, okay, I'm going to ask you a few questions. Please respond quickly. I know we have normal force. Please be careful with the normal force. All right? It's on an inclined, so it goes the way the inclined is. Normal force. Okay? What else? The force of gravity. Now, I want to do something here. Force applied. Where is it acting? Is it up the plane or down the plane? I need you to respond on the group. Up the plane or down the plane? All right, I see a lot of response saying up the plane. It's just pulling it up. There's nothing there. You look confused as if we're asking you. It's just up the plane. Don't try to make any magic. It's just, that's just it. It's just up the plane. All right. Okay, we are done there. That is force applied. But now, the examiner says there is friction. Where should my friction be acting? All right. The last person who sent me a message about this is Oratile, up the plane. Now, what about friction? Down the plane or up the plane? All right. I'm interested in this. All right. Yes, Dash. Down, down, down. I see a lot of downs. I see a lot of downs. All right, guys. You are all wrong. And that's why I chose this question. Please, can we define friction? See, that's why I chose this question. There's something tricky about it. And you should, those of you that know me right now know that I don't just jump into common things. It says the object is sliding down. Now, can we define friction? Friction is a force exerted by the surface on the object, which acts what? Opposite to the direction of motion. What is the direction of motion? Object is sliding where? Down. So where should friction be? I know you guys might not be used to the fact that friction and applied can act in the same direction. Please Guys, please, let's follow the definition. It says friction is opposite the motion, or opposite the direction of motion. Let's use the correct terms. It's opposite the direction. Examiner wants you to, draw it opposite. That's why they gave you this question. Please talk to me. Please talk to me. Are we okay? Yes, no. Yes, no. Quickly. Follow the definition and trust it. Friction is opposite the direction of motion. So because the object is sliding down, friction will be acting up. Lovely. Because once you get the free body diagram wrong, trust me, your next calculation is wrong. Your next one is wrong. I hope we are together. Okay, so now we need to now recalculate. So we are done with that. But now, guys, it's not really so nice to calculate with this diagram. So we need to, and please, this is where learners also miss it. Learners also miss it in terms of resolving the components of the forces. Just quickly drawing that force again, that free body diagram again. All right. So that is kinetic friction. That is applied force. What is this? Force of gravity and normal. It's not so easy to work with this. What we do is we convert it into what? Vertical and horizontal forces. All right. That is my normal. What would I have here? FG perpendicular. What would I have here? FG parallel. Friction. Applied force. So that's my force applied. That's my friction. That's my FG parallel. That's my FG perpendicular. Now, this is routine that everyone should know. Be able to break down the force of gravity into vertical and horizontal. And instantly write down this formula. mg sine theta. While this is what? mg cos theta. Now, the object is sliding where? Down. Always choose the direction of motion as positive. Which forces are we going to use when we say Fnet? Just trying to get a different color. I always choose the direction of motion as positive. So these are the forces that control the object. So if object is moving down, let's choose direction as it's moving down. Let's choose that as positive. What does it mean? It means it's going to be positive, while these two are going to be what? Negative. So instantly, once I'm done with that, guys, I am done with the calculation. Answers lie in your free body what? Diagram. Okay. I know that I don't have friction, right? Formula for friction is mu kn. But what is my n, my dear learners? Normal and FG perpendicular will be equal. So my FK equals to mu k mg cos theta. What is our kinetic friction? 0.29, and the angle is 25. 0.29, mass is what? 100. G is what? 9.8. Cos what? 25 degrees. Guys, like I said, some of these calculations you will be the one to finish up the calculation. So now, can we write our Fnet? Our Fnet equals to what? MA. Which forces are we using? The three horizontal forces. All right, let's start with the one that is positive. mg sine theta minus friction minus applied force equals to what? MA. Can we substitute everybody? What's our M? It's 100, 9.8 sine 25 minus whatever you get there. Somebody wants to quickly do that for me? 257,57. So are you somebody confirming that answer? 257,57 minus F equals to what? 100 multiplied by 0. I'm sure here you can then calculate by using your calculator to get all of that. All right. This one will give me 0, right? So ever I see my answer. I hope we are together. Did that make sense? Amza, are you giving me the whole of the thing on the left? 414,17. Are you sure? All right, if that's the case. So the trick here was your free body what? Diagram. And that's the thing. Alima is giving me 671,74. All right, can we all just quickly confirm? Give me this whole expression. Halima, how are you? Give me this whole expression. Quickly, we're done with this question. That was just the only trick there. The whole thing. Okay, guys, I'm having 156,60. All right, let's just do it. I have 3 different answers. Okay. It's 100 multiplied by 9,8 sine 25. All right, minus 257,57. 156,595. 156,595. 156,595 minus F. Moving F over there. All right, that's our final answer. Thank you, guys. Lovely. So please take note that the trick here was the free body diagram. Follow the definition. Friction is opposite the direction of what? Motion. All right, name the force that will form an action-reaction pair with a normal force in this case. I think that has already been answered. It is the perpendicular of the gravity. So it is FG perpendicular. Remember, action and reaction should act on the same object. Okay. Alima, what's wrong? What happened? You want to talk to me quickly, Alima? So Alima, I'm waiting to hear from you, your expression there. So your force and action and reaction should act on the same object, and they would act in the opposite what? Direction. All right, lovely. So we're done with that. Quickly, let's jump to this electrostatics question. If you had time to do this, we're just going to pass through very fast. A small sphere A carrying a charge of -5. Listen, ladies and learners, always learn to convert your units. Once I see -5, I stop reading. It's -5 times 10 to the power negative what? 6. Please, let's make sure we always convert. All right. So a small sphere A carrying a charge of -5 times 10 to the power -6 coulombs hangs vertically from a ceiling by a means of an inextensible string. Point P is 100 millimeters. Another problem. How do we convert millimeters to meters? We divide by 1,000. So take note. Millimeters to meters, it's over 1,000. So what is 100 divided by 1,000? 0,1. So please let's take note of all of these conversions. To the right of sphere A as shown in the diagram. Let me help you here quickly. Millicoulombs is 10 times 10 to the power -3. Microcoulombs is 10 to the power -6. Nanocoulombs is 10 to the power -9. And picocoulombs is, all right. But these are the 2 major ones that they like using. All right, and your millimeters, let's quickly do that as well. Millimeters divided by 1,000 will be equal to meters. A centimeter equal to your meters. Take note of your conversions. All right. Did charge sphere A lose or gain electrons to acquire charge? Do you want to answer this question? L or G? Just write L or G. Black apex, we divide. Because meters is smaller. All right. Zainab says gain. Are we losing or gaining to become -5? Anybody confirming with Zainab? All right. It's actually correct. Because it becomes negative. Remember, negative shows excess what? Electrons. So the correct answer is it gains. If it loses, it will become positive. All right. Negative simply shows it has excess. Now, calculate the number of electrons lost or gained. Guys, please don't write anything from your head. Go to your formula page. Number of electrons is calculated as Q over QE, where QE is the charge on an electron. All right, so what do we have? -5 times 10 to the power negative what? 6 over -1,6 times 10 to the power -19. You are going to get a positive answer. And that positive also tells you it gains. All right, your answer is a positive. That positive tells you it gains. If your answer was negative, we will be dealing with something lost. Quickly, everybody. All right, whatever answer you get there, just going to run because there's a lot of slides. 3,125 times 10 to the power 13 electrons. And because it's positive, it shows that we are talking about gain. Calculate the electric field at point P due to. Please always try to read due to. And take note, electric field, not electric force. Learners always confuse what to use. All right, thank you guys for all the answers. Beautiful. I am having a 125. No, you have a 124. All right, please take note. There's a difference between field and force. And while we are busy with this, I quickly want to clear a few things. All right. So, let's clear a few things as well. We are looking at electric field. Please, I want you to be able to define. Number one, be able to define electric field. And number two, be able to define electric field at a point. They are different, please. Electric field is the space or region around an object, all right, where an electric force is experienced. Guys, you have your pages or definition pages. Please go through. I'm just passing through and showing you what's important. Electric field is the space, okay, space or region, okay, space or region around the object where an electric force is experienced. But when I talk about electric field at a point, this is where we use this formula. E equals to F over Q. It is the force experienced. So you define, you use your formula page to define. Force experienced. When in physics, this divided means per unit. And what is Q? Positive charge. And we are done. So, electric field at a point is the force experienced per unit positive charge. And what is our unit? F is what? Newton, and charge is measured in coulomb. So this is Newton per coulomb. Just showing you how to walk through as quickly as possible. Now, what is the other formula we have here? E is also equal to what? KQ over R squared. I think that's the one we are going to use in this particular question. Why? Check what we have. We have Q and we have R. So those are the two things that will help us. We have Q and we have what? R. And we are looking for what? E. Can you see the connection? You're looking for E, you've got Q, you've got R, and K is a constant. So what do we have? 9 times 10 to the power 9. What is our Q? Now, when it comes to calculations here, you really do not need the sign. 5 times 10 to the power negative 6. What is our distance? 0,1 squared. What is your answer? I want to show you something. What is our answer? There's something I want to show you here. All right, your answer should be 4,5. Let's do it quickly. It's 4,5 times 10 to the power. You have 9 minus 6 would give us 3. What do you have? 5 zeros. Okay. So it's 4, 5, 1, 2, 3, 4, 5. Are you sure? Yeah. Okay, some of you to give you 4,5 times 10 to the power 6. 1, 2, 3, 4, 5, 6. Yep. Okay, lovely. Jaylene has that. Now, what is our unit? Let me write both. So when you are practicing again, what is our unit? It is Newton what? Per coulomb. However, the examiner did not tell us to find the magnitude. They said find the electric field. Remember, these ones, point charges are always what? Positive. And I know this charge to be negative. What's going to happen? There's an attraction. It means P is dragged towards what? A. Because P is being pulled because of the opposite. So what would I write here? It's going to be towards what? A. Or somebody would say to the left. Very important. I hope we are all okay there. So take note, these are the major things you need to know about electric field, except when we go to net electric field. I'll show you what to do. I hope I do have questions on that. Everybody okay? Quickly give me a thumbs up if we are good on the same page. If there is no question, let me know as well. All right, sweet. So please, you still have the rest of the day. Once I'm done here, I'm going to upload immediately. Go over again. I've got lots of interesting things lined up as we go along. Okay, that's fine. Now, the question then continues, giving us a string question now, going back to Newton's laws. An identical sphere B carrying an unknown charge placed on an insulated stand. I want to first talk about this insulated stand. It's a lovely question they would ask. Why is it placed on an insulated stand? To prevent loss of charges. Because an insulated stand means it doesn't conduct electricity. So charges are prevented from being lost. All right. So it's on an insulated stand, it's brought closer to sphere A. Charge sphere A swings to the right. Interesting. Remember, let's go back. Let's quickly go back. Check how A was. A was just stationary. All of a sudden, we brought a charge, and then we are told it swings to the right. Do you want to tell me something? Why is it swinging to the right? What could be happening? What's the nature of B to make A swing to the right? Anybody? Dash? Okay, I'm seeing answers. Magdia, B cannot be positive because it is pushing. So automatically, because it's repelling, B has to be what? Negative. Remember, it was first stationary. Let me get a highlighter. It was here. And all of a sudden, when we brought this close, it ran away. Like charges will do what? Repel. So examiners want you to also remember that. Okay, I hope we are okay there. Swings to the right and comes to rest. Take note of that word, rest. When it comes to rest, we're talking about it being at equilibrium. That equilibrium is a very important concept. All right? Very, very important concept there. So that the strings make an angle of 30 degrees with the vertical, and tension in the string is 25 newtons. The distance between the two spheres is 50 millimeters. You remember what we said here? 0.05. We divide by 1,000. Okay. You can do your division quickly just to confirm. Is charge sphere B positive or negative? I think we're done by saying negative. Why? It repels A. In whatever way you want to answer that question and explain, the main key is to look for repulsion. Calculate the magnitude of the charge on sphere B. 6 marks. Interesting. Look, when you see such questions, I wish I would do 2 questions for you today. Here. When you see this question, please draw a free body diagram. Quickly. On A. If I were to draw a free body diagram on A, look at what it will look like. I'll have my force of gravity there. I'll have my tension there. Now, there's an electrostatic force that A experiences. It's repulsion. Remember, I am drawing that of A, so A goes to the right. So this is electrostatic force, that is tension, and that is force of gravity. Please draw a free body what? Diagram. Now, once you draw this, remember, we don't want to work with inclined forces. We always want to deal with vertical and horizontal. Okay, let's go do something here. Let me just create a fresh page. So I'm going to quickly draw my force again. It's similar to what we did earlier on. This is what we have. Electrostatic force, tension. Now, which force is inclined? It is this one. Can we change it? When we change, we always change to what? Vertical and horizontal. The challenge is, do you know where your horizontal would be? It will be to the left. Why to the left? That force, you see the way that force is? It's between up and left. Once you get that right, the second thing to get right, I'll tell you now. This is T vertical, TY. This is FG. This is FE. And this is what? TX. I hope everybody's okay so far, following. Let me go back to the diagram. I want to show you something here. All right, so that's our tension there. Check this. If I complete my triangle, we said left and up. So what do I have? TY and TX. Listen, the side facing or the side opposite the given angle, always use sign. Makes your life a lot easier. All right? It's okay, Makdea. The side opposite. If I'm using 30, which side is opposite 30? TX. Just use what? Sine. Don't even, you remember sine is what? Opposite over hypotenuse. So the side, whichever angle you want to use, the side opposite that angle, use what? Sine. So I see my TX. My TX is going to be T sine theta. T sine theta. This will be T cos theta. What are we looking for? We are looking for the magnitude. Now, guys, I cannot get magnitude until I get the force. Let's break it down. F equals to what? K. Q1, Q2 over R squared. But I have a challenge. I don't know the force. That's a big problem. It means there are two unknowns. In fact, if I want to make it nicer for you to see the number of unknowns, F equals to what? K, let's say QA, QB over, yes, I know K. I know R. I know QA. I don't know QB, and I don't know F. In this case, don't think of simultaneous yet. Although, yeah, we can think of simultaneous. Actually, it's simultaneous because I don't know two things. But check here. This is what I'm going to do. Go back to your diagram. We're told that it's at equilibrium. It means the horizontal forces are equal. The vertical forces are also what? Equal. So you need to choose which one to play around with. If my horizontal forces are equal, what does that mean? Electrostatic force, which is that, right? What is Tx? T sine theta equals to, can I just do this? K, QA, QB over R squared. So that's the connection. Do I know my tension? Yes. 25 sine 30 degrees, 9 times 10 to the power 9. Please don't worry about the charges. 5 times 10 to the power negative 6 QB over, I think we said 0.05, right? I know we are all maths learners. Here you can get your QB. We just simplify and cross multiply. The examiner says we should find, just a second, do you see? Magnitude. Already we know the sign. The sign is what? Negative. But we are only looking for magnitude. And your answer would be in columns. Guys, I am done. 6 marks in the bag. We're just going to run to the next question. Remember, you'd need to finish all the last leg calculations on your own. Mine is just to quickly show you the principles. I hope it makes sense. So they can even ask you to calculate the mass. If I want to look for the mass of object of the sphere A, check here. Mass of A. Mass is in there. So vertical forces are what? At equilibrium. So I know my Ty equals to what? Fg. T cos theta equals to what? Mg. Do we know T? Yes. 25 cos 30 equals to M times 9,8. Whatever answer you get in kilograms. We're done, ladies and gentlemen. Oratile worked it out. 225 times 10 to the power 6. Okay. Okay, she had time to work it out. Guys, please make sure you also try to work it out. This is just now maths, not even maths. This is maths lit. You know, cross multiply, then divide. It's the lit of maths lit. Let's quickly look at this one. All right. If anybody also worked it out, you can just confirm that answer for me, and so that people can see what to get and when they do the maths. But let's work it out. I'm interested. Let's work it out. Just so that when you are practicing, you can also see. Many people still get that answer wrong. All right, so this is what I would do. I would say 0.05 squared times 25 sine 30. Now, everything divided by, please, when it comes to electrostatics, use this division line. 9 times 10 to the power 9 times 5 times 10 to the power negative 6. What's our answer? All right, Tilia, what did you get? You said you got, this is what I'm getting. Because we cross multiply 0.005 squared times 25 sine 30. Then we divide both sides by 45 times 10 to the power 3. So this is what I'm getting. 6.94. Anybody confirming? 6.94 times 10 to the power negative 7. 2 decimal places. All right, maybe there's a mistake somewhere. All right, guys, you can also check later and confirm whatever your answer would be. A group of grade 12 learners want to determine the efficient conductor which can be used as a heating coil for a kettle that they are constructing for their ESCOM Expo project. What are we looking for? We are looking for efficient conductor for a heating coil. So something must be hot. Okay. They connected each of three conductors A, B, and C in a circuit and measured the current passing through the conductor and the potential difference across the conductor. Lovely. So they measure the current and the potential. In this case, please remember that your potential difference is the independent what? Variable, and this one is your dependent. It is quickly important that when you have a graph, those of you that have been with me taught you how to deal with graphs. First, you multiply the axis. Secondly, you divide. And number three, you write as what? A straight line. If I were to divide, I'm looking for the gradient here. Change in y over what? Change in x. What's on the y-axis? It's current. What's on the x? Potential difference. Now, the question is, what is this representing? If I go back to Ohm's law says, but V equals to what? IR. Can we divide both sides by I? V over I equals to R. But guys, I do not have I over V. Sorry, I do not have V over I. What I have as my gradient is I over, which is the reciprocal. Can I turn this? And if I turn this, I've got to do the same. What would I have? I over V equals to 1 over R. Lovely. So it means the gradient of this graph is 1 over R. I want to ask you a question here. Before we go and look at all of the questions examiner is testing, please, I hope you got that concept. Find the gradient and use your formulas. Which one has the greatest gradient here? Which gradient is the highest? Or which slope is the steepest? A. Gradient of A is actually greater than the gradient of B, which is also greater than the... This is not math, so please don't tell me that my equal signs are my inequalities. No, we're not doing inequalities. We're saying the gradient of A is greater than the gradient of B, which is also because we're looking at the steepness of the slope. However, your gradient is a reciprocal, which is 1 over. You know what it means? It therefore means that C, the resistance of C, is greater than the resistance of B, which is also, this is now testing your maths. Why? Because gradient is 1 over. It's the opposite now. If my graph was V on the Y and I on the X, then A would have had the greatest resistance. But this is 1 over R. So it changes. I hope that makes sense. All right. Name 2 variables that must be kept constant for a fair investigation. What should be kept constant? I would say number 1, the length of the cable. Number 2, the thickness of the cable. These are very important. Number 3, temperature. All of this should be kept constant because all of this will affect resistance. All right? The thicker the wire, the lower the resistance. The longer the wire, the higher the resistance. The higher the temperature, the higher the resistance. I'll repeat. The longer, the higher the resistance. The thicker the wire, the smaller its resistance. The higher the temperature, the higher the resistance. So all of this would affect what? Resistance. So they must be kept constant. Write down the physical quantity represented by the gradient. I think we are done. What is the physical quantity represented by the gradient? It's the reciprocal. We did that already. Of the resistance. We said it's 1 over R. So examiner wants to apply your knowledge of maths. Which one of the conductors is efficient enough to be used as a heating coil? Very lovely question. Which one is efficient enough? Guys, I want to use formulas to help you see this. Which one will be what? Efficient enough. Okay. Before we come back and answer, we are looking for heat. And heat with what? Power. Now let's conjure our formulas together. Or not even heat. We can talk about energy. Let's talk about energy. Heat has to do with energy. If you check your formula page on energy, I want you to learn how to use your formula. Energy, you would find it as W. W is equal to VI delta T. W is equal to V squared delta T R. W is equal to I squared R delta T. All right. This is where I am going to. Now, what do I have, guys? I have current. Is that okay? And I have resistance flowing. I'm going to use this one. Why? This is the energy that we're referring to, the heat. We're going to have the same current flowing through all of these wires at the same time. All right? Time, we're going to have the same time frame for all of them. And this is what? Resistance. Now, if you look at this formula, do you notice that for the same current and time frame, which is delta T, R or W, which is the heat, is directly proportional to R. I don't know if that makes sense. That is, if I squared, check this. Let me try to explain. I squared times delta T is constant. Watch this so that you can see. Let's use K. W equals to what? K R. Because I'm saying I squared delta T. That's K. What is the relationship between the two? As R increases, W will also what? Increase. They are directly proportional. When something is inverse, it's over. These ones are directly. Oh, so I can then make a conclusion to say, for me to have, the question says, which one of the conductors is efficient enough to be used as a heating coil? Which one will produce more heat? The one with the higher resistance. All right. The one with what? Higher resistance. So what would be our answer? C. Our answer is what? C. Give a reason for your answer. You just come and say, so my answer is C. For the time, all right, frame, why did I say time? Time frame, time. Or for the same time of flow, W is directly proportional to R. Therefore, C, the one with the higher resistance. Let's leave it like this so that it makes sense. The one with the higher what? Resistance. The higher the resistance, all right, the bigger the hotter the conductor. The hotter the conductor. And please, in physics, we always use equations to back up our story. And that is the equation there. You would say, for W equals to I squared R delta T. All right, please talk to me. I hope it's okay. Talk to me. Did that explanation? I just like to go in depth so that when you see other questions, you can apply yourself. Please talk to me. Are we okay? All right, thank you, Zainab. Lovely. All right, Maktia, thank you. Sweet Messiah, beautiful. So always use knowledge of physics. Guys, I don't think this one is, we need to, okay, let's just run through very fast. By 6, I want to switch to chemistry. 2 blocks of masses 2 kg and 5 kg are connected by means of light inextensible string. The blocks are pulled on a rough. I won't really calculate this, guys. I'm just going to break it down. All right. The blocks are pulled on a rough. So it's all rough, telling us there's what? Friction. Okay. Force F. Pulled by force F. The force makes an angle of 20 with the horizontal. Refer to the diagram below. The 2 kg and the 5 kg experience kinetic frictional force of 10 newtons. All right. And what? 15 newtons. And there are a lot of factors that actually determine or the magnitude of the friction. State Newton's second law in words. Oh, that's our national anthem when it comes. Right. When the net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and proportional to mass. Everybody knows that. It's like writing your name in physics. Done. Okay. Draw a labeled free body diagram for the 5 kg. Let's see. What do we have for the 5 kg? We have gravity. All right. We're going to have what? Normal force. Applied force. Actually, with physics, this one should be longer. Now, friction. Remember, the object is being pulled forward. So I'm sure we learned our lesson from the first question. You always ask yourself. Some of you think friction and applied cannot act in the same direction. That's why I brought that first one. So always ask yourself, object is moving forward. Friction must be acting backwards. Kinetic friction. So what do we have? Kinetic friction, Fg, applied force, and normal. You're done with your, there's tension. There's tension in the rope. It's been pulled back. Tension. You are done with your 5 marks there. Don't do any funny, fancy things. Just be basic enough. All right. Now, calculate the magnitude of F that must be applied to the angle of 20 to the horizontal to make the 2 blocks accelerate what? 2 per second to the right. Remember, acceleration is a vector what? Quantity, which must have both magnitude and direction. Now, I told you earlier on, please don't start calculating until you have resolved your forces. Your forces must be horizontal and vertical. So what are we going to do? Quickly here. I'm reinforcing this so that everyone who has been struggling with how to resolve can see what to do. My forces are wrong there. They must be parallel as much as possible. All right. What else? Fg, very long. So this is Fg, tension, friction, normal, applied. Now, can we draw a new diagram? What would it look like? Normal, Fg, friction, tension. Now, this one is where we want to now quickly resolve. It is, check here, it is up and right. Up and right. Because it's right in the middle there. That's how you do it. So, up and right. Can we now make the circle bigger? There we go. What do we have? Fx, Fg, Fk, tension, Fy, and normal. Object is moving horizontally, right? I like to just always do that. They said object should accelerate to the right. Oh, lovely. Object accelerating to the right. Put that there. And choose right as positive. It means that this force will be positive, negative, and negative. I want us to quickly get what our Fx is. To get your Fx, go back to the diagram. Let's go draw it on the diagram. What do we have on the diagram? That and that. Fx and which one is opposite? It's Fy. So F sine. Okay, guys, you are going to finish the calculation. So I know this is F. Which one is again? Fy. F sine 20. It means this will be what? F cos. Okay, so if we say F net equals to what? MA. What are the forces? Fx is positive. The other two horizontal forces are negative. Minus tension, minus friction equals to what? MA. What is this? F cos 20. We don't know tension. I think this one is 15. What is the mass? 5 kg. Oh, we know acceleration as 2. And it's positive because we chose right as positive. So what do we have? F cos 20 minus T. This is 10. If I move the 15 over, 25. I have equation 1. Where will I get the equation 2 from? From the second object. So if we look at the second object, what do we have? Normal, friction, tension, and what? Gravity. So let's quickly draw. I know I'm moving a bit fast. Time is just always also running, but all of this you've done in school. So this is my friction. That's my tension beam stab because we are pulling the object to the right. Normal. Again, keep the same direction that we chose. Right is positive. This will be positive and that will be negative. Okay. So if we look at what is the mass? 2 kg. At the 2 kg, T minus Fk equals to Ma. Our friction is 10. The mass is 2. Acceleration, here we can actually get tension easily. Tension will be equal to what? 14. What do? You throw your 14 back in here, and then you get your applied force. 6 marks in the bag. Okay. So it's something very easy to do. We can then throw that 14 back, and then you do your mathematics. Okay, everybody, I hope we're okay. Newton's law of universal what? Gravitation. Once I see that, I know that they're talking about that. The Earth exerts a force of 1842,5 to keep a satellite of mass 200 in orbit around the Earth as shown in the diagram. Calculate the distance. Since we're talking about universal gravitation, I'm sure we all know the formula. What is it? F equals to what? G M1, or we can say the mass of the Earth and the mass of the other satellite over what? D squared. Do we know F? We do. 1842. I'll tell you where the examiner wants to catch you here. Do we know G? G you check from your page, right? Please don't write it from your head. 6,67 times 10 to the power negative 11. Now, do we know the mass of the Earth? Again, it's a constant there. 5,98 times 10 to the power 24 Do we know the mass of the satellite? 200 over. Okay, please listen to this part. You are going to complete this calculation. D squared. You are going to get your D. But that's not, the question says, that's not the answer. The question says, calculate the distance above the Earth's surface. This D, let me quickly explain. It is the distance between the satellite and the center of the Earth. Please take note. So how are you going to get the distance? Whatever distance you get there, let's understand what that distance is, all right? You need to subtract. So this distance would be D minus the radius of the Earth. And the radius of the Earth is also a constant. 6,38 times 10 to the power of what? 6. Please, I don't know if I made sense there. It goes back to the law and be able to also state the law. I don't know if I made sense, guys. That this distance is between the satellite and the center of the Earth. But what are we looking for? So the D here is the D that we looked for here. I'm trying to get something. This is D. From the center of the Earth. This is the radius of the Earth from here to here. But the distance that the examiner wants is right here. Distance required in this question. Distance above the Earth's surface. So the D you get would be the total length. What do you need to do? Subtract the radius of the Earth. And then you get your answer. It comes from the law that all objects in the universe will attract each other with a force that is directly proportional to the product of the masses and inversely proportional to the what? To the distance between the centers. I hope that makes sense, everybody. So you need to subtract that. There's 2 marks there for subtracting and your final answer. Check here. You would have gotten 1 mark for the formula, 1 mark for that, 1 mark for this. Then subtracting the radius of the Earth, 4th, and the 5th mark. Okay, physics is done. It's all about maths. Guys, I think we did this question. You should be able to. Which one of the following expressions can be used to determine the magnitude of friction? Friction is what? Mu Kn. Examiner wants you to find N. By the time I resolve this force, I'm going to have that. All right. Here and have that. Fn and Fy. If I complete this, the one that is opposite sign. So my Fy is theta. Now, these 2 forces should be equal to that. So the weight is equal to N. Why? What is N? Fy, which is mg minus f sine theta. Can we bring that here? Mu k into bracket what? Mg minus f. This is you dealing with. Easy stuff, guys. You will never walk through until you find the component. Please always find the component, and the one that is opposite, we use what? Sine. Okay, just there's something here very important. The kinetic energy of a car moving at velocity v is k. These questions are very tricky. The kinetic energy of a car moving at velocity v is k. Now, what is kinetic energy? We all know it is half mv squared. Now, the velocity of the car changes to what? To v. What is the new kinetic energy? I want you to check something here. This is the old one. So can I say K1? All right. Now, what is K2? Half m. What is now my velocity? 2v. Please don't cancel. Once you cancel, you're going to lose the whole thing. This is times 4. 2 squared is 4. But what is this? It's that. K times 4. 4k. D. Examiner wants to lure you to cancel. Once you cancel, you'll say there's no answer. Say, no, the answer is not there. There's no option. It's a mistake. No. You cancelled. Oh, easy peasy here. All right? Easy peasy here. We can see that it is moving from A to B. It is always from the positive to the negative. I think we're done here. A is negative and B is positive. Done. A. Next question. Do you want to give me an answer to this one? Let me test your definitions. What's your answer to this one? Let's try quickly. I know I'm moving too fast. Just that I have a few other questions. C. The SI unit for the rate of flow of charges. The rate of flow, that's current. And current is measured in... Done. You know what they would ask me here again? Which other units can we write amperes at? Check. Q equals to what? I delta T, right? No, rate of flow of charges. I equals to what? Q over delta T. What is Q measured in? Coulombs. And time is in what? Seconds. So this is coulombs per, and that's the same as amperes. So should they ask you, use your formulas to get an answer. Beautiful, guys. Lovely. Let's answer these two questions, I think, then. What's next? I need us to answer electricity questions. Okay, I'll just see what other... I need to run to this 7.3 before I move to the chemistry part. I have 15 minutes for physics. But I hope it's been helpful so far, bringing a lot of things back into memory. A block is pulled by force F and moving to the left on a rough horizontal what? Surface. If it's rough, there's friction. The direction of the resultant force and the acceleration are, a block being pulled by F and moving to the left. Net force will accelerate, the net force will cause the object to what? Accelerate in the direction of the net force. The direction of the, because the object is moving to the left. So F net will be to the left and the object will accelerate in that direction as well. All right, because it's moving. See, easy peasy. Can you help me with 1.5? Which one of the following units is equivalent to what? Let's try. What? What? Anybody? Somebody? Zainab says A. Dash, what I say? Everyone seems to be quiet now. Only Zainab said A. Even Dash, yes, quiet. What are you saying? What's your answer? Come on, guys. I need answers, please. right. Okay, Oratile says B, Pahat says C. So I have almost all the options. Who's giving me D? What do you have, Dash? All right, Magdia says C. All right, C got 2 options. 2 votes for C. Okay, let's quickly answer. Now, what refers to what? Power. Now, if you check here, we've got, what's the formula for power? IV. How do we measure current? In amperes. And voltage in V. Do we have AV? Done. It's C. Thank you, guys. C. So the other units they could have would be to say I squared R, which would be what? Okay, maybe, I see. Maybe this is why you chose A, Zainab. There's a squared here, see. If it's like this, then A would have been correct. Zainab, did you see that, right? Okay. So the correct answer here is C. Guys, let me jump away from multiple choice. As much as I'm having fun with multiple choice, let's answer, but let's do one electricity. A variable resistor is included in the circuit below. The resistance of the variable resistor is decreased. Which one of the following combinations of changes will occur? All right. Oh, guys, sorry, this is actually a grade 12 paper, but let me cancel this so that we can answer it for grade 11. Let me do this. So that we can answer it effectively. We turn it into it. This is the only thing that makes it grade 12. That small r. Otherwise, everything is grade 11. Now that we have removed it, somebody stole it. Escom stole it. Okay, for load shedding purpose. Now, what will be our answer? Let's answer this. We know that V, it's now a bit simpler, equals to what? IR. Is that okay? And we know that current and resistance are what? Inversely proportional. So when the current, the question now says that, this question is not going to make sense here though. It's not going to make sense because of the voltmeter reading. Okay, let's try. The voltmeter reading will not change in this case. Let's see if there's going to be an option because it's just this, the battery remains the same. All right? The voltmeter reading will not change, but if resistance, they said, what happens? Resistance is decreased. What will happen to current? Current will increase. Okay, this unchanged. Let's change the whole memo. But I hope it makes sense. Just by changing that thing there, it changes the whole question. But just know that resistance and current are inversely what? Proportional. All right, ladies and gentlemen, I'm going to leave this for you. Yes, very important. Grade 11, you'll be tested on this. 2 charges are brought together. Calculate the new charge on each other. See, I'm jumping because of time. Do I know my Q1? Let's see. 2 identical sphere charge Q1 and Q2 are placed on insulated stands. Okay. Let's just quickly, I'm not going to finish the calculation, guys. Run into chemistry. The charge on Q1 is, remember what I told you, they will always give you that. What do? We change it, right? Times 10 to the power negative 9. 40 centimeters, what do? Divide by 100. 0.4 what? Meters. Now, we know that the force of attraction between the 2 spheres is that, this makes it easy. F equals to what? K, Q1, Q2 over R squared. We know F, we know K, we know Q1, we know R. Guys, that's on you. What do we do when the 2 charges are brought together? Q new would be equal to what? Q1 plus Q2 divided by 2. This is what I want to quickly say on this one. When they ask you to calculate the number of electrons transferred, what do? We come back to this, right? But please take note. What is this Q? This Q is actually Q new minus Q old over QE. Please take note. N equals to Q over QE. But what is that Q on top? Remember, you will have gotten the Q new from here, right? Q new minus Q old divided by QE. That is the number of electrons transferred, either lost or gained. All right. I'll send you the slide as well. I think my major thing that I want to do here is on this. After this, I'll jump to chemistry. This you can all do. Oops. I chose some lovely questions, but time. Oh, look at lovely. Look at this monster here. Look at this monster here. I'll try to find. One thing about me, sometimes I just don't remember where I get the questions from. I just continue. But I'll try to find whichever one I cannot do right now, send you a memo, do the questions and mark. All right, I'll try. I hope I still have my system opened to check where I got the questions. All right, let's look at this one as the final one for physics and then run to chemistry. Point X is 0.6 meters to the right of charge QB, which has a charge of positive 2 times 10 to the power negative 6 as shown in the diagram. All right, we draw the electric field pattern due to QB. We can all draw. Guys, I want to go to 7.2.3. All right. I want to go to, but we cannot do 7.2.3. Let's see, can we do it? No, we can. We can. A second charge. So we know our QB. What's our QB? Positive 2 times 10 to the power negative 6. Second charge QA. Positive 6 times 10 to the power. All right, we're good. This is what I want to do. It's now placed 0.1 meters to the left of QB, as shown in the diagram below. Calculate the magnitude of the what? Net. Guys, once you see net, you start by drawing a free body what? Diagram. But they said at point what? X. X is a point charge. Point charges are always what? Positive. Now, this is what you do, guys. I'm going to draw a free body diagram at X. And I'm going to take them one by one. A and X. What do you notice? A is positive. X is positive. They are going to what? Repel. Let's push it up a little bit. They are going to repel. And we are looking for A, for E, and electric field. So E of what? A. What about B? B is positive. X is also positive. They are also going to what? Repel. Okay. Now what do you do from here? Write as positive. What is our E net? Since both of them are positive, we go back to Newton's law. EA plus what? EB. But what is E? KQ over R squared plus KQ. But which A? Q here. QA and, all right, what do we have? 9 times 10 to the power 9. Guys, you're going to substitute your QA. I just want to deal with the distance. What is the distance between A and X? 0.7. And again, 9 times 10 to the power 9. You're going to substitute QB. What is the distance between B and X? 0. There was one I was looking for. I didn't get it. But if I look for it, I'll find it. I need you to try that one. Something similar. All right. So you're going to get your E here, guys. Choo-choo. Very fast. Look at this next one. Calculate the magnitude of the net electrostatic force. There are two things they will ask you. They can ask you to calculate here. This is Number one, the force. 7.2.5, the acceleration of the electron. Calculate the magnitude of the net, again, there isn't what? Net electrostatic force. That an electron, so what are we looking for? We're looking for F. Guys, once you see this as a sequel, a continuation, it is this. F over Q. E net, F net. We would have gotten our E net from here, right? What are we looking for? Net force. And we know the charge on an electron. All we need to do is to substitute. So take note of that. And I added one lovely piece. Acceleration of, someone says, huh? Acceleration, yeah. But this is electrostatics. Yes. The electron would run because it's negative. It will either run towards, but in this case, it will run towards X. F net equals to MA. If you check your formula page, I don't know if you have ever checked. So the F net would come from here. The question is, what is M? If you check your formula page, the E is what you call the mass of an electron. It is 9,11. So this is the mass of an electron. 9,11 times 10 to the power negative 31. A. And then you can calculate. So please take note. That's what physics can bring, can just hit you unexpectedly. If they want acceleration, now we know what to do. All right, guys, I hope that physics session was quite helpful. All of this, like I said, I'll send you the answers. I just hope I remember. And this electricity question. This one here is what Eastern Cape wrote today. No, somewhere this week. Okay? So a friend of mine sent me this. I just asked him to quickly send it to me so it's not so clear. But I'll send you the whole paper. All right? I'll send you both paper 1 and 2. I know Gauteng kids, you're writing just one paper. They wrote 1 and 2. Okay? I'll send it to you today. Send you the memo. Do it, Mark. If there's any issue, you let me know on your groups. And, yeah, we can move on. Same thing with this one. Came from the same paper. You would notice there's electrostatics there again. This is very interesting. This was taken from a grade 12 paper. I love it. Okay, and when I say I love it, you should know. Yes, they're going to ask you for a free body diagram here. Okay. If I were to do this quickly, let me just draw the free body diagram so that it makes sense to you. Do you know this one is positive and this is what? Negative. So there's an attraction there. Okay. What would happen? There's a rope there holding that guy. So there's tension. Is that okay? Let's read. Calculate the magnitude of the we want the magnitude of the tension. Beautiful. Which forces are acting on Q1? There are 2 forces. All right. There is Fg and an electrostatic what? Force. All right. So what's happening is the negative is actually attracting Q1. Okay. So we have an electrostatic force, which is what? K, Q1, Q2 over R squared. Meanwhile, there's also what? Fg, which is equal to what? Mg, and there is what? Tension. That's why the free body diagram is 3 marks. So how would you calculate the magnitude of the tension? At equilibrium, the force upward should be equal to the forces acting downwards. Fg plus Fe. And that's why if you read the first thing, do you notice the first thing was they gave you mass? Although we didn't read. 2, each of mass 5 grams because they know you need it here. K, Q1, Q2 over, and remember, in chemistry, in physics, we work with what? Kilograms. So this is 5 times 9,8 over 1,000. Plus your K, your Q1, your Q2, and the distance between them, Remember the distance to be is to be divided by what? 100. Guys, that's how it works. It's more of applications. I hope we're good. So that you are not really surprised that, oh, we never did this. No. All right, let's do some chemistry quickly. Which one of the following is correct about an exothermic? Heat is released to the environment. Okay? Heat is released. Let's quickly write a few things there. Heat is what? Released. And if it is released, what do we know? Delta H is a product. These are a few things. All right. The products have higher enthalpy. Okay, where is enthalpy coming from? HPR minus HR. Now, if this thing is negative, for delta H to be negative, what does it mean? HR must be greater. And what is the graph? While we're here, exothermic, exit. This is what I do. It's always easier for this guy to get out. It's closer to the ground. Exit. And what is this? Reactant, product. And what is that? Activation what? Energy. What is that? Activated what? Complex. And right in between these two is delta H. I'm sure everybody remembers that graph. So what's our correct option here? The products have a higher enthalpy. Nope. The reactant releases heat and therefore higher energy enthalpy. The heat of reactant is greater than the heat of product. Let's read through first. The heat of reaction is positive. Nope. The reactant absorbs heat. Nope. So it makes sense where we were, because we said heat is what? Released. Oh, beautiful. Beautiful. The energy diagram below shows changes in potential energy for the reaction between sulfur dioxide and oxygen. And again, you will see it's exothermic. How do I know it's exothermic? All right. Define activation energy. Minimum amount of energy. Reaction to do what? To start up a reaction. Calculate the I love this one. Guys, can I please ask you to do this one for me? 6.1.2, everybody. Calculate the activation energy for the reverse reaction. I'll give you 2 minutes. This you would find again in multiple choice. Yes, it will be there in multiple choice. Give me a value, please. Guys, it's either you are lost. I'm lost. I don't know. I'm not sure. We are looking for the activation energy. I got no answers at all. Are we lost? Please, I need to get a feedback from you. It's easier for me to know where you are. All right. Ain't you getting tested on this tomorrow? You sure? Wait, guys, are you not getting tested on this? Let's see. Let me quickly check. Someone sent me, Bonolo did send me that thing. Let's quickly check. Please, somebody confirm, so we don't waste our time here on this. I'm checking also here. Oh, we're not. Oh, sorry, my bad, guys. Guys, why are you saying you're not? What is energy and chemical change? Are you guys smoking something? Okay, wait. Please check for me. Okay, please somebody recheck for me. Okay, someone sent it to the group. Let's see. Let's see. Oh, you're not. Okay. Because the one I had energy and, oh, okay. All right. Okay, you're not getting tested. But let's see. Let's just answer it for fun, for the fun of chemistry, right? Okay. For the fun of chemistry, activation energy is always measured from the top. Now, if I'm looking at the reverse, this becomes my reactant. So basically, I am looking at the 480 minus 120 would then give me what? 360. It was that easy. Kilojoules. So if it's the reverse, that becomes my reactant, and activation energy is measured. All right, guys. Okay, let's leave all of this then. Let's do acid and base. Sorry about that. Sulfuric acid ionizes. Please give me an answer. This one we must get right. Which one is the correct conjugate acid and base pair for this reaction? 60 seconds. 60 seconds. You already have 45. Oh no. All right. I have an option that says C. I have another option that says D. Remember, when an acid donates a proton, it becomes a conjugate base. I want more options. Nilufa says C as well. I want one more. When an acid loses a proton, it becomes a conjugate base. And when a base accepts a proton, it becomes a conjugate acid. All right. Let's see. And that's it. All you need to do is to identify which one is your acid and which one is your base. And if you check, H2SO4 is an acid because it donates. How do I know it donates? My 2H there becomes what? 3. So this is an acid, and this one accepts. It's a base. When an acid donates a proton, it becomes, whatever is left, it's a conjugate base. When a base accepts a proton, whatever it becomes, and you're just looking for your pair. And they always look alike. The difference is always one hydrogen. All right. Woo. This is now redox. Strip of magnesium is placed in a zinc sulfate. Mg, you have metal strip there, zinc sulfate. The reaction that takes place is represented by a balanced equation. Which one of the following is true? Okay, guys, let's just quickly look at it. Let's start by writing. I don't think we need the table here. Let's start by writing oxidation numbers. I hope we all still remember how to get oxidation numbers here. Oxidation number of a solid, that's 0. Another solid here in a free state, 0. All right, zinc is going to be 2 plus. Mg is going to be what? 2 plus. That one is going to remain the same. It's called a spectator ion. So what is oxidation? The loss of electron or the what? Increase in oxidation what? Number. Okay, so please get your definitions. This one moved from 0 to positive 2. We call it oxidation because there is an increase. This one moved from positive 2 to 0. We call it what? Reduction. Why? There is a decrease. So let me quickly help you with something. Mg is oxidized to Mg2 plus. It means Mg is a reducing what? Agent. It's always the opposite. Zinc 2 plus is reduced, you see on the right, to zinc. So zinc 2 plus is an oxidizing what? Agent. Let's see. Is any of these options there? Zinc is an oxidizing agent. Wrong. I said zinc 2 plus. Don't be tempted. Mg is a reducing agent. Do we have it? Yeah, but we do. The other ones we don't have. Mg is reduced. We said Mg is oxidized. Zinc is oxidized. No. It is Mg that is oxidized. So I hope I was able to make that clear. Use oxidation what? Numbers. An increase in oxidation number is oxidation. Let's quickly do that definition here. Oxidation. There are two definitions. Number one, loss of what? Electron. And number two, increase in oxidation number. And definitely the opposite would be what? Reduction. What is reduction? Gain of electron. And number two, what do we say? It's a decrease. And I hope everyone can calculate oxidation number. You will be told to calculate that definitely. Anyway, some stoichiometry here. 7.5 grams of impure. Guys, please, I always like to simplify things, and I'm going to simplify this for you. I'm going to show you something very important here. Stoichiometry will only work in 3 ways, guys. No matter the stoichiometry. 3 steps. Before you go to number of moles, let's quickly take a small 3 minutes crash course. Stoichiometry. Look, every variable or every quantity is linked to the number of what? Moles. What do I mean? If I want mass, number of moles is mass over molar mass. If I want concentration, it's number of moles over volume. Or number of moles is mass over molar mass and volume. If I want volume, number of moles is volume over molar volume. If I want number of particles, number of moles is number of mole and number of particles over Avogadro's what? Constant. Everything is linked to what? Number of moles. If you get this in grade, I promise you, grade 12 is a walkover. Now, here's this. They will not give you the number of moles you need. That's one thing you must know. Now, what are your steps of calculation? Step 1, find the number of moles that reacted. Please take note, that reacted. Of the other compound. They will give you information about another compound. Step 2, use mole ratio to find the number of moles that you need. Just take a screenshot of this for those of you at home. And step 3, calculate what you need using N from step 2. I promise you that everything surrounds this little thing that I wrote here. Almost all stoichiometry can be done if you understand how to navigate. They wouldn't move outside of this. And all you need to also remember are the other formulas, right? You must know how to calculate percentage purity, mass of pure substance over total sample times 100. And let me quickly just add this on one slide. Only pure substances react. Then percentage yield. Actual yield. Again, it's all number of moles over what? Theoretical yield multiplied by what? 100. These are the basic calculations you need. Take a screenshot of this for those of you at home so we can just quickly get done. All right. And if you take a screenshot, please just send it on the groups that you're in. I think I have 4 different categories of people here on 4 different groups. Just share the information as well. All right. Now let's go. So we're going to use this as our guide. I'm sure you've taken a picture. We're going to use this as our guide when it comes to stoichiometry. Check this. 7.5 grams of impure. Once you see that, it's percentage purity. Of commercial washing soda, which is it has water of crystallization, that 10H2O. It's dissolved in 500 cm cube. Please, people, we don't work in cm cube. It's dm cube, right? So what do we have? We divide by 1,000. 25 cm cube, again, there's a problem. It's 0, what? 0.25. I just like to work in dm cube. Of this solution is titrated with a standard hydro. Please, you will be tested here. Define a standard solution. A solution of known what? Concentration. A solution of known, you will be tested on that. A solution of known what? Concentration. So once you know the concentration, it is called a standard solution. Now, I wanted to check something. Guys, I want to show you how to get the 6 marks very easily. Calculate the mass. Check this. Calculate the mass. Let's stop there for a while. How do you calculate mass? The number of moles is mass over molar mass. I told you, everything is connected. So that's my first statement. Everything is connected to what? Number of moles. Check my next statement. They will not give you the number of moles that you need. See, I'm looking for the mass of NaH2CO3, sodium carbonate. All right? However, they won't give me, if they gave me this N, guys, it won't be 6 marks. But I told you they won't give you N. What will they give you? They'll give you information about the other substance with which you can calculate the number of moles. Now, if 24,8 cm cube, everybody, so basically I'm working with these two. Now, for HCl, let's make a list of what we have. Okay, we will change. Let's make a list. Go back to the original question. What do I have? Concentration. I have the this is why I love to change, because it's mole per dm what? Cube. Now, they said if 24,8 cm cube of this solution was needed for reaction, what is my volume? 0,0248. Is that right? When we remember, convert all the time and divide by what? 1,000. Thank you, those of you that sent the pictures. Please always just make sure that you divide. It's safer that way. Do you notice that I can calculate? This is what reacted. Do you notice I can calculate number of moles here? What is my step one? Find N that reacted of the other compound. Okay. So C equals to N over what? V. Let's walk through. What do I have? 0,1 equals to N over 0,0248. What is N? 0,00248 moles. Does that make sense to us? This is the number of moles that reacted. Okay? Now, what do we do? Ken, what's our step 2? Use the mole ratio to calculate the number of moles that you need. Oh, step 2. Na2CO3.10 H2O. All right. What do we have? HCl. What's the ratio? 1:2. So if I have this is HCl, remember? We work with HCl here. So if I have 0,00248, what will I get? We cross multiply. What will N be? 0,00124 moles. I don't know if we are all on the same page there. Talk to me. Are we all on the same page? I need you. Before I continue, are we on the same page? So remember the trick. You will not be given the number of moles of what you need. The examiners will do what? Will give you information based on the number of moles of a substance. You need to calculate the number of moles that what? Reacted. When you do that, then what do? You use the mole ratio. You never use mole ratio until you get the number of moles that reacted. All right. Just a second. Lovely. Yeah. Now, can we calculate mass over molar mass? What is the molar mass of sodium bicarbonate? Calculate the mass of pure that in commercial what? Okay, if 24 cm cube was needed to... Okay, just 1 second. By the way, just hold on, just 1 second. Let's quickly get something. The number of moles that we got, watch this. This is where just the inside trick is. We are using this calculation. Let's go back. I want us to get something. 7,6 grams of impure commercial washing soda is dissolved in what? 500 cm cube of water. Is that okay? So we have a solution. Out of that solution, what did we take? We took what? 25 cm cube. Is that fine? It means here we actually used 25 cm cube of the sodium carbonate. So what we did was, first was we calculated the number of moles there, right? And we said, according to mole ratio, we have 0,0124 moles. Of which compound? But here is just an additional information. Still, our step 1, step 2 is there. This one is contained. So 0,00124 moles is actually what we have in 25 cm cube. All right, 0,025. How many moles do we have in 500 cm cube? I don't know if you get what I just said there. We only used this calculation here. This whole titration was based on 25. So we got the number of moles in the 25. But we're going back to the original. Because the question says, calculate the mass of sodium bicarbonate in commercial washing what? Soda, which is this guy. So what do we do here? Can we cross multiply and divide? I need answers. Let's cross multiply and divide. So the one we got was present in 25. But if we take it back into the original, it's going to be 0,00124 multiplied by 0,5 divided by 0. This is where the little trick is. What do we have? 0,0248. That is what is present in 0,5. Now, number of moles is mass over molar mass. 0,0248. We don't know the mass. Step 3. Can we calculate the molar mass of Na2CO3? Let me do that here. Na2CO3 dot. Some of us don't know how to deal with this 10H2O. Sodium is 23. Multiplied by 2 would give you 46. Carbon is 12. Oxygen is 16 times 3. Now, when you see dot, it's plus 10. Hydrogen is 1 times 2. And oxygen is what? 16. Do you want to give me an answer quickly? 46 plus 12 plus 48 plus 180. 286. Okay. There you with your calculator. Just cross multiply. What is 286 times 0,0248? Such a lovely question. 7,09. Sorry, 7,09. Okay, grams. That's what is present. 6 marks. And what they can do now is to calculate percentage purity here. If I want percentage purity, what would it be? Mass of pure over total what? Sample. Dash, you take a picture. Percentage purity would be what? 7,09. Total sample is what? 7,6. And then multiplied by 100. Should they ask? What's your answer here? $90 something. 289. So 29%. So 93,289. So it's 29. What is the percentage impurity? It is 100 minus 93,29. And that will be 6,71%. Should they ask you for percentage impurity? Guys, that's how easy stoichiometry can be. All right. Please take a picture. Those of you at home, take a screenshot as well. And see the steps. Please see the steps and understand. Take a picture. Try to make sense of the steps again. Step 1, calculate the number of moles that reacted from the other substance. Use mole ratio. But this time around, the mole ratio we got was in 25 cm cube. The original is 500 cm cube. So we took it back to the original system. And then calculated the mass. And this is percentage what? Purity. Mass of pure substance over total sample multiplied by 100. All right, guys, that's how to deal with your stoichiometry. Let's do another acid and base. I know this is where learners always kind of struggle. And after this, I think we'll deal with intermolecular forces. Let me see. Oh, redox, then inter. Oh, we're good. We're trying to cover everything as fast as possible. Sodium carbonate ion ionizes in water into sodium ions and carbonate ions. All right. Carbon ions in solution undergo hydrolysis. Don't worry. Don't worry about defined hydrolysis. I don't know whether you guys do it in grade 11. But don't worry about that. It's a grade 12 piece that I just took some grade 11 concept. Hydrolysis, reaction of salt with water. Anyway, 7.1.2 is grade 11. Give a reason why the solution of bicarbonate in water is alkaline. Alkaline means a base. Let me use red. Why do you think it's a base? They said by referring to the substances in the equation of. Guys, why do you think it's a base? Quickly, I need you here. Why do you think this is a base? This is a very important and interesting question. Anybody? Oh, sweet Zainab. No, it doesn't receive electrons here. We cannot say it receives electrons. Use the reaction above. So this is actually asking you to define a base. It is a base because hydroxide ions are formed. What is a base? A base is a substance, according to Arrhenius. A base is a substance that forms what? Hydroxide ions when dissolved in water. Please go and check. This is a base in terms of Arrhenius. A substance that forms hydroxide ions when dissolved in water. So because of that OH minus is called hydroxide what? Ions. Because of that, a substance automatically is a base. If it forms hydronium, then it is an acid. All right, 7.1.3. You want to do that for me? Write down the formulae of the two acids in this equation. 60 seconds. Two acids in this. It's basically you're looking for conjugate, and then you can get it from there. 60 seconds. Already I've given you extra time. All right. So all we need to do is, look, check. If you look at this, H2O and OH minus, what do you notice? This guy must have lost one proton to become that. And if it's donating, it's an acid. So we have a proton that is lost. So this is an acid, and this guy receives, it's a base. When an acid donates a proton, it becomes a conjugate base. So this acid donates and becomes this. It becomes a conjugate base. A base will accept and become a conjugate what? Acid. Already I'm done. Two formulas that are an acid, water and HCO3 minus. That's how we check. And what is an ampholyte? A substance. Give a reason why this can act as an ampholyte. It can donate and receive a proton. That can act as an ampholyte, can donate and can receive a proton. All right? So it can act as an acid and a base. Okay, we're moving quickly. Oh, that was just that. I think the rest was grade 12 piece, so I cut it out. But at least these are some grade 11 concepts tested here. Let's quickly answer. It's now raining here. Let's deal with this question here on redox. So I do redox, guys, 10 minutes, and just talk about boiling point and melting point. And we're all good. The rest of the questions you can please try to answer. Limiting reagent. Oof, this is blurry. Okay, that will be it. Let's just... All right, let's quickly look at this one. The reaction between magnesium metal and hydrochloric acid is an example of a redox. Okay, define oxidation. I think that has been done already. We did that earlier on today. Look, whenever you see an equation like this, quickly, guys, write oxidation numbers. 0. Hydrogen is positive 1. Chlorine is negative 1. Hydrogen here is 0. Chlorine is negative 1, but there are 2 of them there. It gives me negative 2, which makes magnesium to be positive what? 2. Which one is increasing? Let me write this well. So please go back and check on how to calculate this. 0 to 2. And then 1 to 0. So Mg is oxidized to Mg2 plus, which means Mg is agent. Then what do we have? H plus is reduced to hydrogen gas, which means H plus is the oxy. Remember, they are always opposite of each other. All right. This one is done. Write down the formula or symbol of a substance whose oxidation number does not change. Do you notice? Which one? Cl. It was -1 before and -1 after. Write down the symbol of the reducing what? Agent. I'm done. What is it? Mg. Explain in terms of oxidation what? Number. What happens? Oxidation number does what? Oxy. Is it increasing or decreasing? Mg increases. Please, from 0 to, that's where your marks are. From 0 to positive what? 2. Write down the balanced reduction half reaction. Do you know how to write this? Which one is reduced? Plus. Let's go to the table quickly. You'll be given a table. Let's go find H plus. All right, I'm going to magnify this so that everyone can see. Check here. This is where H plus is, guys. I want to show you how to get this done. This is where H plus is for you in grade 11. You found it, right? Now, so this is what we have. Everybody, I'm going to write it out here. Plus 2E. And what do we have? H2. Oxidation number here, positive 1. What's the oxidation? 0. Can we quickly go back to our equation? What is our oxidation number? for hydrogen. We need to write it the way it is. It's from positive 1 to 0. Oh, it's actually the same way. Let's go back to see. Do you see? It's from positive 1 to 0. That's my equation is already set. So what will it be? 2H plus 2E. Quickly. All right? Plus 2E. But this time around, you don't write a double arrow. You write a single arrow. H2 gas. 2 marks. Okay? Guys, are we okay with that? Did that make sense? All right, let's quickly answer the last question here. 7 marks. In another, let me do this. Let's cut out all the other stories. So we've gotten our 2 marks there. Now we want to get 7 marks. How can one question be 7 marks? So a learner who doesn't understand redox reaction will be losing 7 marks just like that. Yet, hello, someone saying something? All right. In another reaction, Fe2 plus is check. Fe2 plus is oxidized. Oh, lovely. Oxidation. By dichromate ions in an acidic medium. The dichromate are reduced to what? Don't stress about the names. They told us Fe2 plus is oxidized to what? How do I know? What's the oxidation number? Positive 2. What's the oxidation number? Positive 3. By dichromate, okay, the dichromate ions, Cr2O72 minus, are reduced to what? Cr3 plus. Check. My oxidation number here is, guys, I want us to calculate the oxidation number of Cr here. How do we do it? There are 2 of them there, right? So I'll say 2Cr plus, oxygen is what? Negative 2 always, but there are 7 of them. Which means negative what? 14. And this should be equal to what? Negative 2. So 2Cr equals minus 14 equals to what? Negative 2. What do we have? If we move that, there becomes positive, right? Which will give us what? 12. So the oxidation number of chromium here is what? 6. So please take note. And it makes sense now. When they say it was reduced, it was positive 6, it's now what? Positive 3. So it makes sense. Write down the balanced equation for the what? Net redox by using the ion electron what? Transfer. When they say ion electron transfer, you need to write the oxidation first. You can write reduction first, doesn't matter. Okay, let's go check. Which one is oxidized? Fe2 plus to Fe3 plus. Please, at your level, I'll ask you to go to your table. If you're in grade 12, we can write that without a table. All right? But at your level, we are looking for... Now, there are so many ions. Please be careful. You are looking for Fe3 plus and Fe2 plus. I'm going to quickly show you how to find it. Okay, guys. It's big enough for everyone to see. I'll stop. I'm having Fe here, but it's not 3 and 2. Yeah. Okay, there we go. All right, you'll have 2 tables. The tables are just the same. Check there. But look at what you have. You have Fe. This is how we have it on the table in case, just to make it clear. Plus E. You see what I'm looking for, right? I'm looking for 2 plus and, but check. What is this? Positive 3. Please watch these numbers. It's positive 3 and positive 2. In our own equation, let me take this very close to my page. Okay, my board is now refusing. All right. If I take it very close, remember this is positive 3 to positive 2. What do we have here? Positive 2 to positive 3. So I've got to go back and write it nicely. I must 2 because it's oxidized. So oxidation, what would it be? Start from the positive 2 plus, changing sides. Fe3 plus. Please, I hope it makes sense. Because it must go in order. Positive 2 to positive what? 3. The electron must go with the other one. So what do we have? Fe2 plus. And when you write, we don't need to write 2 arrows anymore. It is Fe3 plus that. You can see it's obeying what we said, oxidized from 2 to 3. Okay, dichromate. Let's go look for it. Cr2O27 minus and Cr3 plus. Let's go together. Use the table again. If anyone finds it, just holla, holla, holla. Oh, I found it quickly. I found it. It's right on top here. Check it. That's it there. If you have your table, so what's the equation? It is Cr2. No, why am I using a highlighter? Cr2O72 minus plus 14 hydrogen plus what? 6E to give us what? 2Cr3 plus 7H2O. What's the oxidation number here? We calculated positive 6. What's the oxidation number here? Oh, it's exactly the way we want it. From 6 to 3. Make sense? So can we go write that down, everybody? Cr2O72 minus plus 14 hydrogen plus 6E to give us what? Cr3 plus plus what? 7H2O. My dear learners, are you aware you have 4 marks already? Out of 7 marks. What do? We want to balance. Do we know how to balance? What do? The electrons must be the same. And for me to have the same electrons, what do I do now? Multiply. I'm going to multiply this one by 6 and then multiply this one by 1. Somebody's saying, but where is the 6 and the 1 coming from? 6 electrons and 1 electron. So you just switch the numbers. All right. Now let's quickly multiply and we are done with this question. 6 Fe2 plus 6 Fe3 plus 6 electrons. What do we have when we multiply the other one by 1? Cr2O72 minus plus, we're multiplying by 1, remember? Plus what? 6 electrons. Let me do this. Just move it a little bit. And then what do we have? 2Cr3 plus 7H2O. Now since our electrons are now the same, for balancing now, you are going to get your 1 mark. Electrons are now the same. What do I do, guys? Write everything that's on the left. Just write it down. What do we have? 6Fe2 plus 2O2 minus 7 plus 14H. Write everything on the right. Already there's 1 mark there. Everything on the right. 6F plus 2Cr3 plus 7H2O. And now for balancing. Let us check how many marks. 3 there, 4 on top, 7 marks in the bag. All right. The last 5 minutes, I won't really dwell it much on that question other than to summarize for you. Is that okay? I'll summarize for you the last one. We're talking about intermolecular forces. Be able to define. Okay? And one thing I know is that a substance with a high boiling point will have what? A low vapor pressure. There are 3 definitions that you should learn tonight quickly. Boiling point, or there are actually 4. Melting point, vapor pressure, and temperature. Check your definition pages, they are all there. But a substance with a high boiling point would have a low what? Vapor pressure. Now, what are the factors? Right now, they are going to ask you for intermolecular forces. The stronger the intermolecular force, okay, guys, let me do this. Let me first write this. The stronger the intermolecular force, the higher the boiling point. But we don't write that in an exam. The higher the boiling point, and the lower the vapor pressure. You've been writing this? All right. But here's how to answer in the exam now. Easily. When you want to answer in the exam, guys, we are going to use the principle I call ICE principle. To answer in the exam, we are going to use what? ICE principle. ICE. I want to just do something here. ICE. This is the easiest way to answer. The first one, I, means to what? Identify the type of intermolecular force. Intermolecular what? Force. And basically, there are 3 of them. All right, someone is playing around with the screens. Please, can we not change the setup? All right. Identify the type of intermolecular force. Look, there are going to be 3 of them that you would be using. London, dipole, and hydrogen. Where do you find hydrogen? Hydrogen and oxygen. Okay, I normally say fun. Fluorine, oxygen, and nitrogen. So if you have things like, check this, like HF, like H2O, like ammonia. Do you see all of those? It is hydrogen and fluorine, hydrogen and oxygen, hydrogen and nitrogen. And hydrogen is very strong, right? So first you identify. Where do you find London? You are going to find London between hydrogen and a halogen. Between X is halogen. Hydrogen and what? A halogen. And what do you find there? You find what? Dipole what? Dipole. London, hydrogen and other compounds, other elements. Okay, so these are basic, this is just a summary. There could be more. For example, hydrogen and carbon. You see? Hydrogen and carbon. Hydrogen and silicon. All right? All of those are just London. Now, what do we do? C. So once you identify element A or compound A has hydrogen, compound B has dipole, you identify. Don't write too many stories, 1 mark. Compare the strength of the intermolecular what? Forces. Which one is stronger? I could actually take these lines off. Which one is stronger? Hydrogen is stronger, right? Hydrogen bond is the strongest. So identify, compare. So hydrogen bond is the strongest. London is the weakest. So you compare, and when you compare, use comparison. All right, hydrogen bond in A is stronger than the London in B, or hydrogen bond is stronger than the dipole in B. Use compare then. Or hydrogen is stronger than the dipole, or dipole is stronger than the London. Just know the strength. And number 3, talk about what? Energy required to do what? To overcome the intermolecular force. A stronger bond, or the stronger, let's say the stronger the intermolecular force, the higher the energy needed. So you see in that, so much energy is then needed. Then you can make a conclusion that if high energy is needed, if high energy, then we talk about what? A high boiling point, which is also relevant to a low what? Vapor pressure. Ladies and gentlemen, I'm hanging my boots. I tried to summarize what you'll be writing. Did it make sense, guys? Some people just leave. Wow. Some people just leave the group. Did it make sense? Did it help? Some people just exit. Guys, it's just rude to exit. You know, now you've learned what you need to learn. You just poof out the door. No. All right, I hope it makes sense. I will send a slide for you. The other questions that I did not touch, I'll quickly look for the memos. I'll send you 2 papers right now, paper 1 and paper 2, written by Eastern Cape, and send you the memos. Please do the papers and then mark. Whatever topic you did not do that will not be tested, just keep it. Okay? You have your schedule that will be there. So just do it. Enjoy yourself. I'll upload the video. You want to rewatch something quickly, and, you know, that's it. I'll send the slide as well, just almost immediately. All right, guys. Thank you for thinking. And good night. Happy night rest. And good luck with tomorrow's paper. Bye, everybody. You may please log out. You may exit the class. Thank you, guys.